Hey, um, so I'm going to be talking about a biological laboratory today. It's going to be specifically carbon-based biological laboratories because I do not have much of an idea of what a silicon biological laboratory will look like, or if there's anything needed for a virtual laboratory other than a computer and a robot. So of course you need like soldering things and wires and stuff. Um, but I'm going to talk about carbon today. Um, I guess there is a fourth option that I could talk about where it's carbon, silicon, and virtual biological laboratory all at the same time. Carbon based, silicon based, virtual based biological laboratories. Who knows what the particle, cell, cellular automata, dot thing will be called. But, beside the point. So, so, you know what a laboratory is, right? I'm sure people watched TV shows where there are laboratories. It's basically just a room filled with tech that allow you to create things. So what is biological? Well, the bio life hasn't really been defined yet. Like I have an old high school biology book, or I had, with like 7 characteristics of life. I do not remember them. Wikipedia doesn't give 7 characteristics of life. It just has paragraphs explaining why it doesn't have it, or something like that. So I just decided to make up a definition for life on my own. But we're going to take a look at biological first. Um, so the suffix ical means things pertaining to. Log is the root word of biological. So logos is like the oldest version of the word logic. Really the oldest version of the word is log because that's the root word. And if I was to look at etymology, I'd have a better explanation. But I haven't looked at the etymology of biological for a very long time. So I'm not 100% sure what logos has meant in the past, what logic has meant since, your Indian hodgepodge language. Paleo, I can't remember what it's called. It's half European, half Indian, though. Of course, with Middle Eastern language. That was Sanskrit. Okay, that's all totally beside the point. Okay, so I define life for our purposes as biofexes. Life is a complex network that interacts with the environment and is codable. Cool, my thumb went right to it. Great. Perfect. So, codable. That is the big part. I was skipping ahead in my brain while I was thinking right there. But, let's talk about a few things. So here's my lab that I drew in 2011. So that was my idea for a lab. Those were the things that were around in 2011 that I would have built my lab on. If y'all take a closer look at that picture, there was no DNA synthesizer. I didn't know about DNA synthesizers. it just wasn't a technology yet. I'm sure people thought of it, but I did not. I thought I was going to have to order nucleic acid strands or proteins or hodgepodges of those things, and then put them in a machine that copies them a million times, and then use pipettes to squirt it into cells that I pre-bought. So there was a lot of me spending money on structures of carbon. That was what that initial picture was like. Then I drew this one about 7 months ago. This is, how long ago was CRISPR discovered? Maybe 2 years ago, tops. 2 years tops. Maybe 4. I don't know. Anyway, by this point, if y'all have been watching my channel for the last 3 years, 3 years ago I came up with an idea for a DNA synthesizer, for a black box that did a ton of stuff. Not just the synthesis of DNA, but also getting the DNA into a cell, and doing chain reactions for me, and cutting where I need things to be cut. Basically all I need to do is type into the computer, and the code, the physical structure appears in the cell. Yeah, that's what a black box is. So this is my picture of my lab, what I think it will look like in the very near future. Less near future than this picture, than my laboratory that I made 7 months ago. That could be made right now. This lab right here is not ready yet. None of it's patented, none of it's being produced that I know of. So here's a representation of a black box. It looks like a laptop, if y'all can see it. I don't know if you can. I can't see it on my phone. It's too gray or something. But I type into this DNA synthesizer, right? And the code I type is this little red line. So I type in this code and I click send. Where's my marker? It's in my pocket with my lighter. So I type up my code, my program, my genome, and I plug it into this interactome, this cell. Well, I plug it into the computer and it appears in the cell through magic, science magic. And this is what it would look like in the cell. So the cell was pre-made because the DNA synthesizer, the black box, doesn't synthesize proteins yet. But let's just say it does synthesize proteins, and it synthesize. It could be like a 3D printer and just print one cell out. It would literally place carbon atoms everywhere, and because it's a computer, it would do it effectively and quickly and everything. But that's at the atomic scale, so who knows how long that's going to happen for. What's probably going to happen is cells are just going to be mass-produced through CRISPR and genetic engineering. That's all beside the point. Anyway, so I code the genetic information, I put it into the cell, and then the cell is in this extracellular matrix. Have y'all ever heard of a petri dish? It's like a cup. It's like a cup, but it's only this tall. It's only as tall as this white rim at the top. And it's filled with proteins and nutrients and all that good stuff. What if I had an egg, right? A glass egg that was filled with this extracellular matrix with proteins and nutrients and dirt and whatever, it doesn't matter, yolk, and there's a cell in there that has a code that I encoded into it, that I injected into it, and I coded myself. Yeah, so then, just like our virtual intelligence, we proliferate it, and then we have whatever we initially designed in the rules of interaction. Who knows what it would look like when it develops, when it matures? Who knows? That it will take a long time for us to be able to map out the trajectory of a complex system. I'm sure of it. But so I've been talking a lot about organ design, not organismal design. I've been talking about a lot about organ design. That is because I am working with robots right now. They are what kind of robots? Smart robots. I'm working with smart robots right now. Have y'all ever seen the videos on, like, wherever you watch your videos of the robot that, like, plays soccer and, like, can sword fight another person? Yeah, so that robot is a smart robot. I'm sure it doesn't have an AI in it. I'm sure they didn't virtually program particles to develop into a brain. Why they wouldn't, I do not know, but yeah. So that is a smart robot. It has programs that are complicated and can do really cool things, like any app on your phone, except for those apps are for movement and for spatial coordination. So I'm designing a brain for a robot, for a smart robot. How cool is that, first off? Second off, that's not how we have to do things, right? I've done a lot of explaining about virtual-based biological development, but my focus has been on designing a brain. My focus has been on designing an organ. That does not mean we cannot design organisms the same way I design a brain. We start off with the initial cell, carbon-based in this case, silicon-based in the future, virtual-based in the more near future, and carbon and silicon and virtually based in the further future. But in all cases, we start off with an initial. Not all cases. I'll get to why not all cases in a second. And it's because of me and us watching this video. In the near future, we always start off with an initial particle. And then we grow that particle, that cell, that silicon cell, that cellular automata. The initial one turns into an organ or a brain or an organ or an organism or something else. Who knows? Who knows what needs to be structured? It could be very small. It could be smaller than an organ. Organelles are things inside the cell, but that's beside the point. So, yeah. another thing I wanted to talk about was genetic engineering of humans, modern humans, right? The last true humans, the last truly carbon-based intelligences. We are the last generation, you know? After people around my age, give or take 100 years, um, we'll be looking very different. Anyway, I can't for the foreseeable future. There is no way I am genetically engineering myself because I have an immune system that is very effective and I am very enormous. Like this is 1 trillion cells at least. My brain is 100 billion, so I'm assuming there's a lot of cells in my body. So it would be very hard to reach them all. Not even considering the guard that is my immune system. So I'm not gonna look like a monster anytime soon. I'm not gonna look like how I want to look. Because I've always wanted to look like the bad guy. Yeah, I think I'm gonna end the video now. Bye.